everyone, welcome back. Another session here, and actually, we're going to invite a speaker we've already seen back, which is quite nice on the Global AI community. This time, though, we're going to be talking a little bit about enhancing document Q&A with chart understanding. So, this is definitely quite an exciting one. I feel like being able to understand what's going on in our data and our charts is just as important as what's going on in any of our other data as well, if not more so, right? Interpreting it is the last step. So with that, if we bring on Prerna, that would be amazing. Hello, welcome back.
Good to see you
Hi,
again.
thank you.
I didn't know we were going to see you twice. This is lovely. Thank you for coming back. You did a wonderful first session. I'm very excited about the abstract for this session. We won't take any more time from you. Are you ready? Have you got your screen shared just there?
Yes, I'll just share my screen.
Wonderful.
Great.
Whilst we are doing that, as always, a reminder, do go to globalai.community/conference if you want to earn your attendee badge for this event. Go create an account, watch the stream there, and you will be entitled to one. And with that,
Okay.
we can now see your slides. So I think we're ready to go. And yeah, over to you.
Thank you. So, hello everyone. Today we'll be talking about chart understanding for document Q&A. And I'm Prerna. Before we start, here's a little about myself. For people who did not attend the previous session, I can just give a quick intro. So, I'm currently working as an applied scientist at Microsoft in Redmond. And I'm a part of the industry AI team at Microsoft, where I develop different machine learning solutions for different customers in the sector of finance and sustainability, basically different industry verticals. And prior to that, I was a part of the Bing search team where I developed deep learning models to understand the documents on the web. And I've been in Microsoft for about 2.5 years now. And prior to that, I was a master's student at Carnegie Mellon University. And before that, I was doing my undergrad in India. So I'm excited to be a part of this conference and would love to connect with folks on LinkedIn as well. So please feel free to reach out. And with that, let's get started with chart understanding. So why do we need chart understanding? So charts are omnipresent. They're present in documents in form of bar graph, line charts, pie charts, histograms, and so on. They are useful to get important insights from data, and they are also useful for making informed decisions. But inferring key insights from charts can be quite challenging and time consuming. So therefore, we want to have a machine learning model which can understand the chart and do the hard, difficult things for us. So now the next question is, how do we formulate this chart understanding problem? So in literature, there are two ways that you can handle chart understanding. So the first one is as a summarization task. Given a chart image, you want to send that as an input to a model, which kind of summarizes the key insights, useful things inside the chart and gives you a good summary. Another way to look at chart understanding is in form of Q&A. Given a chart image, we want the model or chart data, we want the model to understand and to understand the data inside that chart, and it's able to answer questions like, okay, for what value of X, the value of Y is highest? What does the trend of data look like? So is it able to answer those kind of questions for us? So that comes under Q&A problems. So these are the two ways how we can, how we can formulate chart understanding as an NLP problem. So in this talk, we will be looking at how can we solve chart understanding problem. And later on towards the end, we'll look at what are the challenges or drawbacks in the current solutions and what can be the future direction of research for this problem. So based on my research, I found that the current solutions fall in two categories. One, which leverage OCR-based methods for chart understanding, and then the second, which include multimodality. So now we will be looking at what these categories are, and then we'll look at some of the crucial works or important papers and models in each of these categories. And then towards the end, we'll just discuss about the future direction. So let's get started. So first is optical OCR or optical character recognition based methods. So before we dive into those kind of methods, we need to understand what is OCR. So in layman terms, you can consider OCR as, extracting text from an image. So here you see an image of a credit card, and OCR can help you extract the card number from that image. Similarly, it can help you extract the information from a car's license plate. So OCR uses, different vision techniques or even sometimes deep learning techniques to extract text from an image. So from charts perspective, this can be really useful. OCR is known to have high accuracy in extracting text from an image data. So we can leverage that for chart understanding. It's very easy to, um, understand that from OCR after understanding what OCR is. But there are some downsides as well that, OCR can be computationally very expensive. And in case we have a labeled graph like the one on the top, which has, numbers and everything written, extracting using OCR can be useful. But in the cases where the graphs are more complex and they don't have labeled data, it can, OCR may not be so useful in that situation, because even if you extract text from the image, we don't really get information as to what 2015, what is the value of our English, what is the value of science. So even with OCR, those kind of problems are not solved. So the other direction is of using multi-models. So here what we can do is, instead of using OCR, we can have end-to-end machine learning pipelines, um, which can take image as the input, output the corresponding summary, or it can take image and text as an input and can output, summary of the chart, or the underlying data table, or any text output. Or it can have something like image along with some numeric values, which we can feed into the model and get the output. So these are the two broad categories. Now we will jump into some research papers. We'll look at some state-of-art models in this area, and we'll see how they solve this problem. So the first paper that we look at is Chart to Text, a large-scale benchmark for chart summarization. So this paper came in April of 2022. And this problem solves chart understanding as a summarization task. So given a graph image, as you can see here, given this as an input, we want our model to output a summary, summarizing key or important facts, important takeaways for a chart image. So for this problem, let's see how they formulate it. So for them, the task is chart summarization. And the training data that they used consisted of four components. First is the chart image, denoted by C. Then they have data table, which is T, which corresponds to the underlying data table, which was used to create that chart. And third is the metadata M. This includes, title, type of the chart, whether it is a bar graph, line graph, histogram, or the labels. And lastly, S, which is, those golden summaries corresponding to the charts. So they've split the problem into two versions. So the first problem that they call is V1 problem, where the input to the model is the chart image, the underlying data table, and the metadata. And the output we want from the model is a summary. The second version of the problem that they defined is basically input is chart image and the metadata, and the output is the summary. So here we don't have the underlying data table, and this is more realistic because in general, when you have chart images, it's more like in real life scenario, you always get chart images. You don't necessarily always have a corresponding ground truth underlying data table available for you. So the first baseline that they talk about is inspired from image captioning, because in image caption, what happens is we send an image as an input and we get a corresponding, caption describing what's happening in the image. So that's where they took inspiration from, and they created this first baseline where the input is the chart image. It goes through a vision encoder, then a text decoder, and then we get a corresponding summary. Now they developed other solutions for this problem. So the solution for V1 aspect, where the input is chart image, underlying data table, metadata, they fine-tuned BART model and the T5 model, which are sequence to sequence models. So what they did was they said that since we already have the underlying data table, we can just not use the image as well. We can just use the underlying data table and the metadata in form of a string, and we already have the golden summaries. We can use that to fine tune our model on chart summarization task. And for T5, they added this to the prompt. They added this prefix, translating chart to text, and then again parsed the the underlying data table and the metadata, and use the summary to fine-tune the model. Now for the V2 case where we did not have the underlying data table, they used OCR. So what they did was they took the chart image, they passed it through an OCR pipeline, extracted all the text in the image, in the chart image, and then that text along with the metadata was used to fine-tune BART and T5. So this was the solution that they came up with, and through this, at least on the research side, they provided these models, which kind of acted as a baseline for the methods that came afterwards. So now we move to more recent work, which is the Matcha model, enhancing visual language pre-training with math reasoning and chart de-rendering. So this paper came in the summer of 2023. And this paper is an OCR-free method. They proposed an OCR-free method. They proposed an end-to-end visual language model for chart understanding. So they proposed two new pre-training tasks for chart understanding, and the thought behind that is quite interesting. So the first idea is to have a layout understanding. They said that in order to have a complete understanding of a chart image like this, we need to have the layout understanding, which means we need to, which includes number extraction and their organization. So we don't not only want to extract the text in those chart images, but we also need to have some kind of layout information as to where that number is. We need to have this positional information along with the extracted text uh, to have this layout understanding. And the second aspect is once we have extracted all the text and the layout information, we need to have, our model needs to have this reasoning capability to able to figure out, okay, this is how the trend looks like. This is for this value of X, this is the value of Y. For this value of X, the value of Y is lower than as compared to this value of X or something like that. We need to have that reasoning aspect, mathematical reasoning. So they designed two pre-training tasks to incorporate this into the model. So these are the two pre-training tasks they propose. So first is chart de-rendering. So given a chart image as input to this model, they want to output the underlying data table or the code which was used to generate that chart image. So this was the first pre-training task. This is called the chart de-rendering task. And the second was mathematical reasoning. So for mathematical reasoning, they gave some logical questions to the model, and the output was the answer to those questions. But one interesting thing is that for these logical questions, they sent in an image of the question as input. So the image was sent as an input to this model. So this is the Matcha model. And this showed better results as compared to all the previous methods using BART and T5 and, um, caption generation models. And here through chart de-rendering, they kind of captured both the text that is inside the chart and also the layout information, because if you see the output here is a table which is kind of a structured data, and it implicitly captures everything. It captures the text inside the chart image as well as, okay, for this value of X, this is the value of Y. So in form of a structure, it captures everything. So this is how they trained this model, and this model showed good results as compared to previous methods. And this model can be used for summarization and visual question answering. Now we move to the next version of the model, which is dplot. This is one-shot visual language reasoning by plot to table translation model. And so here, the idea was to leverage large language models. So here, what they did was they simplified the chart understanding problem and thought that maybe we can use large language models, which we know are already good at understanding and logically reasoning out from a given data. So they decompose the problem into two parts, and they say that the first part, we will just solve this plot to table translation. So given a chart image, we want to output the underlying data table. Once we have that structure ready, we can just convert it into a string format and send it into a large language model. And then we can ask it to summarize, or, we can do Q&A on top of it, or, based on the prompt, we can do multiple things with it. So this was the main idea behind dplot. So they used the same architecture as the Matcha model, and they continued to train for plot to table translation. So this is how the overall flow looks like for dplot. This is my chart image. I pass it through dplot model. The output will be a table it basically predicts the underlying data table which was used to create this chart image. And once I have this prediction, which kind of gives the table, the entire table, um, I can pass it to a large language model along with a prompt. A prompt can be a question, or I can just say a prompt that can you summarize this table. And then once I have that, I have my I can do all the tasks. I can do Q&A, I can do summarization, I can ask all kind of analytical questions. And I can also use it to generate code for that as well, generate a new plot or use that data to, combine it with some other data and do multiple things. So that was deep plot. So till now what we saw is we saw three papers with, which introduce kind of different methods of solving chart understanding problem. But this problem is not completely solved. Though these methods are good, but they are not perfect, and there are a lot of areas of improvement that we can work on and research on. So for example, though those models work good on, bar graphs, label data, there's still some issues when it comes to complex graphs. Let's say we have multiple line graphs on the same in the same image. So here, as a human, for me, it's easy that, I know that this blue line corresponds to year 2019, and this orangish yellow line corresponds to year 2020. And I can, if given this task, I can easily, point out that for January, this is the value, it's $20, and for March, let's say it's $60. But when we pass this to to dplot or a model or all the models that we discuss, the model kind of confuses between the two lines and the performance is not as good. So when it comes to complex charts, we still need a better method. Second area of improvement could be there's still not enough data sets to work with, and that's one area probably we all can contribute to. Third, evaluation metric. I think finding a right evaluation metric for charts is still a pressing problem. Um, for example, even for summarization, how good is this summary? Is this good enough? And even for Rouge scores and accuracy, they're not always the ideal situation. For example, if you look at this bar graph here, and let's say my model predicts for English in 2015 instead of 30, it predicts 28. However, if my model is able to get the entire and trend of the data, is that good enough for me? In that case, I don't need to go to accuracy. Maybe I need a different evaluation metric. However, if accuracy is what my customer needs, maybe that's what I need to, maybe mean square error or something else will be a better evaluation metric for me. So we don't have right now, we develop evaluation metric as per our own needs, but I feel like that's one area where we can contribute a lot to find a good evaluation metric specific to chart problems. So that's one area. And these are all the references to the papers and the uh, tutorials that I refer to, and which can be useful for people when they want to dive into this topic. And yes, that's all from my side. I'm open to questions now.
Amazing. That was a really great session. Another great session. All around the data side of things. I've not really seen a lot of that type of interpretation. I've seen obviously some of the stuff with kind of showing what we're doing in Power BI and stuff like that, and it feels kind of similar. I don't know how they're doing that underneath, but it's there's definitely the value around it. One bit that shocked me, and I hadn't really thought about it, because you kind of go, yeah, great idea, like pass it in, it'll give you a nice sort of structured, easy to read summary out, but it's not necessarily correct. You called it out right, like it might not quite get that data correct, and people are quite specific about their data. I certainly know I have to explain every data point if I'm going to kind of propose data and business ideas based on them at work. And so that was a really interesting callback. Is that a setback for those models in general, for those solutions, and packages?
So I think it is dependent on the use case, what problem you're trying to solve. Because I said that there is, limited amount of data. Most of the problems that have been solved or the solutions that have been proposed work on similar one kind of data set. But for your problem, you might have to generate a new data set, fine tune it. And also these models are way smaller as compared to large language models.
Mm,
So there is a lot of scope in that area that, that their learning is very limited in that sense. So
yeah.
that's why it's an interesting area of research.
That is so interesting. And the fact that it takes an image and is able to break that down with the OCR part. OCR is a bit like what we saw earlier with the audio.
Hmm.
These aren't necessarily things we couldn't do before. They're either improved, like on traditional methods, or it's like a more efficient approach to it, isn't it? Of kind of how is it asking those questions? How is it returning the information to us that's maybe less numerical, less statistically delivered like traditional, and actually is able to give more language driven pieces as well. So yeah, really, really interesting session. I saw you linked all those papers. I think the call out from all of your sessions have been dive into these papers, right? They must tell you so much. I think some people feel intimidated by that. Like, is that something like is there a place you go for the ones that are easy to access, for example?
So from my personal experience, I like to read research papers because they provide a lot of detail.
Mm,
But for people who feel a little intimidated by it, probably starting with reading on blogs about it because it's, all
yeah.
simplified and they're just to the point can be a good starting point. But for someone someone like me who wants all the details and wants to focus on every small detail, I like to read papers because
Yeah,
of that reason.
Love that. That's a good breakdown. Now we know you better as well, so that's good for next time we have you chatting with the community. And just a quick one, sort of, what was the inspiration for you to go and explore these different packages? It's an interesting area. Was there a specific project you were working on, for example?
So that's a great question. So usually when we do document understanding, we mostly focus on text. But as a human, when I read a document, I just don't focus only on the text. I also look at the pictures. I also look at the tables, and then I try to make a sense of everything. And
Yeah.
everything kind of contributes to my understanding of that piece of document. So that was an inspiration that why do we leave out on the images? Why do we leave out on the tables? It's not just the text part that we understand as humans. So I think it should be the similar case for even a machine learning model. When I feed it a document, it should have a complete understanding end to end of that document, not leaving some images or, So yeah, that was an inspiration
yeah,
behind all this work.
and that's totally true, right?
Mm.
Yeah,
Yeah, I know. It's got
yeah,
you've got to have a rounded understanding of something. You take in as much information as possible. If anything, I'm probably terrible. I probably lean towards the imagery and the tables and stuff like that over the words. Sometimes you're a bit like quick skim read. That's probably not ideal.
yeah, yeah, yeah,
And that's true. And especially for charts, they tell you so much more
yeah,
rather than the text. Just looking at a diagram of or a pie chart or a bar graph, just looking at it, you understand so much more even before going to the text. So there is a lot that we can learn from. I feel that machine learning models should also be able to understand that and give that information to the readers.
yeah.
A quick one though, because I always find this with Power BI, for if you send a graph or a chart into something like this, I guess you have to make sure that the X and Y axis are labeled nicely, the title is clear, like, not the sort of like names of columns in your actual
Mm-hmm.
database that you've brought in where it doesn't actually make sense to anyone that's like human readable in some
Yeah,
senses. So I guess, yeah, you've got to have nice clean charts, well organized. You couldn't just put in something you'd created in like 2 seconds maybe, because it just wouldn't be super clear, or the summary would come back and I think it would be quite hard to read potentially unless you knew the data source. So that's anyway, we're diving in way too deep here. Apologies, finding all sorts of issues when actually, what a wonderful session, and you showed us something that I've certainly never seen before. So,
yeah.
really appreciate another 30 minutes of your time. So, thank you for donating an hour's worth of your time to this conference today.
And for your great content. Thanks a lot.
It was a pleasure. Thank you.
All
Bye
right,
bye.
we'll see you later.
So we're now out for a small break, and then we will back with another session, and this time around prompt flow. Looking forward to that one as well. See you in a bit.